So Evan and I gave talks on the work we were doing at PagerDuty, and we saw a lot of engagement and people being interested in it, but they really didn't know how to get started. And so we felt like what needed to exist was some sort of like document that would help them think about the problem space and start building their own networks.
Yeah, we gave a lot of talks on this topic, and one of the most frequent questions that we would always get is like, where do I go learn more about the stuff you guys are talking about? And the unfortunate answer was pretty much like, there's not a whole lot out there, so come talk to us afterwards. We're happy to talk to you. And it's kind of like the switch went off, like there needs to be more material about this. And we had the opportunity to write the book, and we don't really usually write, but when we had that opportunity, it was like, well, this might be our chance to kind of like rectify this problem within the industry. Zero trust networking is a security model, actually, in which you don't place any trust in the network. And Doug and I built systems like this back at PagerDuty in the public cloud, and cross cloud. So that was kind of really important at that time. But we see also kind of this evolution towards, like more rigorously securing internal networks. And the logical extension of that is, well, like we know how to secure like internet resources, and it's just in the past it's just been very tedious. And so zero trust networking is all about using automation to gain that kind of like internet security within your internal networks as well, and kind of like make that soft chewy inside more like a hard crunch, like a Skittle versus a M&M.
Doug, anything to add to that?
No, I think he covered it pretty well. I think it works really well. I think like those environments give you APIs for you to discover what's actually running on your network, and so you have much better visibility. And it's almost a prerequisite, I would say. Like you could certainly build it in a non-cloud, non-DevOps enabled environment, but it would be a lot more work.
And like cloud environments kind of lend themselves naturally to this idea, right? A lot of folks have a hard time understanding why they should do zero trust when, hey, like I own all these switches and routers and I own all these racks in my data center. Like why should I be worried about someone screwing around in them, right? This is kind of like a high like mental barrier to adoption of zero trust. But when you're operating in the public cloud, it's a lot easier to reason about. It's like, well, there's a lot of other people out there and they're all kind of right next to me, maybe in the same rack or same machine. Like, should probably beef this up a little bit more than we do on premise. The reality is that like we look towards this model to solve the way that attackers move through networks and the way that attackers perform reconnaissance and lateral movements within a data center. So the reality is like it's not so much about like, hey, I don't trust my switches or routers or servers. It's more kind of like, hey, look, we think this is a really effective way to stop all like most modern threats that we see, and particularly the propagation of those threats within the data center.
Yeah, I think so. You all do a really great job of helping people build up these fine-grained policies they need to actually have this type of security. And specifically, like the machine learning element is really cool because it helps people get to like those base policies without just giving them a task of saying like, we made a policy engine, good luck writing that policy. I think most people appreciate that.
Yeah, and one of the core tenets of zero trust too is getting away from defining policy in terms of like network primitives. So like IP addresses, ports, things like that. These are really, really poor ways to describe network policy. The Edgewise approach kind of gets rid of that, which we really like a lot. And it's actually an approach that we took at PagerDuty as well, where you define this high-level policy, X should talk to Y, right? And then let the computers figure out, okay, what does that actually mean, and how do we actually implement that enforcement under the covers?